Most essential learning competency. Investigate the effect of temperature to the speed of sound. Our objectives are the following. 1. Determine the effect of temperature on the speed of sound. And 2. Compute the speed of sound in air at different temperature.
Hi everyone! Welcome to our Scientastic class. I'm Teacher Bregeline, and I am here to help you understand how science works in everyday life. Are you ready to join me for today's lesson? Come on, let's learn together. To start with, I want you to hear this song.
Akin ka na lang, akin ka na lang, aninatasan sa araw.
Thanks, Mike. Mike is my former student. This is a line from a famous song, Akin Ka Na Lang. Akin Ka Na Lang has a heart-piercing lyrics, but it is a great song. Today, class, we are going to learn about sound energy. Let's have a warm-up activity. Try to touch your throat and feel as you speak. What did you observe? Correct. You felt vibration. It means sound produces through vibrations. Sound is a form of energy and most of it used to create tunes and music for entertainment. Our gadgets like phones, iPads, laptops, and others are sound embedded on it to amuse us. Sound is very useful in the field of geology, oceanography, and medical purposes. What comes to your mind when you hear the word sound?
Sound is a physical sensation that stimulates our ears and it is associated with our sense of hearing.
You're correct. Sound is composed of waves of compression and rarefaction in which the human ears are sensitive.
In your previous grade level, you have learned that sound waves are longitudinal waves that exhibit characteristics features such as frequency, amplitude, wavelength, period, and wave speed. Sound waves have two parts. We have compression and rarefaction. In compression, air particles are close together. In rarefaction, air particles are spread out. Sound is a form of kinetic energy that results from the vibration of particles in a medium. When we say medium, these are the materials sound waves can travel. It can travel through solid, liquid, and gas. Sound travels fastest through solid, slower through liquids, and slowest through gases. Temperature is a condition that affects the speed of sound. Like sound, heat is a form of kinetic energy. As the temperature becomes higher, molecules gain more energy and vibrate faster. So when the molecules vibrate faster, sound waves travel more at a fast speed. On the other hand, when the temperature becomes lower, molecules loses kinetic energy and vibrate slower. So when the molecules vibrate slower, the speed of sound decreases. Therefore, when the temperature of air increases, the speed of sound also increases. Sound moves 344 meters per second through 20 degrees Celsius in air. However, if the air temperature is 0 degrees Celsius, sound moves through it at a speed of 331 meters per second. Why do you think so? Because as the temperature of air increases, molecules of air collide more often because they are moving around faster. As a result, Sound waves move through warm air faster than it moves through cool air. Since molecules in solid and liquids are close together, temperature has less effect on the speed of sound through them. Let us analyze the picture. Sound is also refracted. During daytime, the air is warmest near the ground and cooler away from the ground. It means that the hot ground warms the air and the sound waves travel faster. This makes the waves refract upwards. While during nighttime, the air is cooler near the ground and warmer away from the ground. This means that the air is colder by the ground, so the sound waves are refracted towards the ground. This is why you can hear sound from a greater distance at night. The speed of the wave is affected by the number of vibrations produced per unit of time. This is also known as frequency. The higher the frequency, the faster the wave travels. The formula to find the speed of sound in air is V equals 331 meter per second plus 0.6 meter per second over Celsius degree times T, wherein V is the speed of sound, T is the temperature of the air, 331 meter per second is the speed of sound in dry air at 0 degrees Celsius, and 0.6 meter per second over Celsius degree is a constant factor. Let's try this sample problem. What is the speed of sound in air of temperature 25 degrees Celsius? Our given T or temperature equals 25 degrees Celsius. We are required to find the speed of sound or V. Our equation we use is V equals 331 meter per second plus 0.6 meter per second over Celsius degree times T. Our solution, we are going to substitute temperature into 25 degrees Celsius using the formula. Therefore, V equals 331 meter per second plus 0.6 meter per second over Celsius degree times our temperature, which is 25 degrees Celsius. Next step, we are going to cancel out the degree Celsius. Therefore, V equals 331 meter per second plus 0.6 times 25 meter per second. If we multiply 0.6 and 25, the answer is 15. Therefore, V equals 331 meter per second plus 15 meter per second. The next step is you are going to add 331 and 15. The answer is V equals 346 meter per second. Our final answer is 346 meter per second is the speed of sound in air at 25 degrees Celsius. Did you know that dolphins and toothed whales have exceptional hearing? They use echolocation to hear. Similar to bats, even if they have bad eyesight, being blind for the most part, therefore, they rely heavy on their hearing. Echolocation is a technique to determine the location of objects using reflected sound. Did you know that acoustic is the science of sound? Did you know that an echo is a single reflection of a sound wave of a distant surface? And reverberation is the reflection of sound waves created by the superposition of such echoes. If you have ever sung in the shower, then you have probably experienced a reverberation. The Parvati-like sound which you hear is the result of reflection of the sounds you create combining with the original sounds.
This is all for today, class. See you next week. Bye!